Okay, we're going to look at distance time graphs this week, continuing on from this work you were doing on speed, distance and time last week. We're going to start by looking at different distance time graphs and what they show. So this first distance time graph, we've got distance on the y-axis, time on the x-axis and a steady diagonal line, and this shows that the object is travelling at a constant speed. Okay, in this one we've got a slightly steeper diagonal line to start with. Okay, again, object travelling at constant speed, a little bit faster possibly this time, and we can tell that because this line is steeper than in the previous graph. And then we've got a flat horizontal line, and that shows that the object has stopped. We know it stopped because the distance on the y-axis isn't increasing. Okay, we've got a flat line here. The time is increasing, but not the distance. So this tells us that the object has stopped moving. Okay, again, as I said previously, a steeper line shows the object is moving faster. In this graph, we've got a steady speed here, moving away from the starting position, and then the object turns and goes back at a steady speed, a slower steady speed, because this line is not as steep as this one, going back to where it started from at a steady speed. Okay, so we know it's come back to where it began because we're back down to 0 on the distance. Okay, so the distance from where it started from is pretty much the same over here as it is here. So we know it's come back to where it started. Okay, slightly different curved line here. This shows that the speed is changing. So when the speed is increasing or going faster, we have a steeper line. When the speed is going slower, it's a smaller gradient. Okay, so this curved line shows that the speed is changing. It's either increasing or decreasing in speed. Okay, so this slide just summarizes the 6 graphs that we've gone through, and you can refer back to these to remind yourself what each of these graphs means. So straight, steady line is constant speed. The steeper that line is, the faster the speed. This one, the gradient is much smaller, so the speed here is slower. And a flat horizontal line means not moving. If the line is returning back down to the x-axis, okay, then that shows that the object is coming closer to its starting position. And this curve here, sorry, flip back, has this habit of jumping. This curve shows that the vehicle or the object is accelerating because the line is gradually becoming steeper. Okay, so we're just going to look at a typical distance time graph and interpret what each of the different stages of the graph mean. So stage 1, the object is moving away from its starting position at a constant speed. Stage 2, we've got a flat horizontal line, so it's stopped. Stage 3, it's moved off again, but a slower speed than previously, and we can tell that because the gradient is smaller. It's not as steep as the gradient at stage 1. And then lastly, stage 4, the object is moving back towards its starting position at a constant speed. Okay, so just to remind you of the speed, distance, time triangle we used last week to help work out the questions. And as most of you should know, the calculation that we're trying to find, if we're trying to find distance, we would cover up the distance part and do speed multiplied by time. If we're trying to find time, sorry, this does jump when I use the mouse. I'll better not use the mouse. So if we're trying to find time, we do distance divided by speed. If we're trying to find speed, you would cover up speed and do distance divided by time. Okay, and that's the one that most of these questions are going to focus on. We're going to be working out speed from a distance time graph. Okay, so we've got an example here. So if we start off by just looking at the graph that we've been given here and interpreting what it means. So we've got Laura going for a cycle ride to the post office 4 kilometres away. So she's moving at a constant speed here. She's cycling at a constant speed. She then stops from 11:20 until 11:40. She has stopped, so presumably that's when she's in the post office. And then she travels back home to where she started from, again at a constant speed. Okay, so first question asks us, how long did it take Laura to cycle to the post office? Okay, so we can see that she left at halfway between 11 o'clock and 11:10. That looks like 11:05. And she's arrived, if we go up to here, she's arrived at 11:20. So she's been travelling from 11:05 to 11:20. We can take the 5 minutes away from the 20 minutes and work out that it took her 15 minutes to cycle to the post office. Okay, we're then asked to work out her speed. So we know speed is distance divided by time. Okay, so we want to divide the distance that she's travelled by the time that she took. Okay, so the distance, it tells us, is 4 kilometres. You could work that out by looking at the graph, and you can see that it's 4 kilometres here, but we're actually given that information in the question. And the time is 15 minutes. Okay, so this is where it gets a little bit more complicated. So normally we would be given her speed in kilometres per hour. It's quite rare to see kilometres per minute, but the time that we've worked out that she took to travel there is 15 minutes. Okay, so I would first convert the 15 minutes into hours. So if we think of how many minutes there are in an hour, there's always 60 minutes in an hour. So the method in order to turn minutes into hours is simply to do 15 divided by 60. Okay, so the number of minutes divided by 60 will give you the time in hours. Okay, and a lot of you will know that 15 minutes is a quarter of an hour and a quarter is 0.25. But if you don't, that's the method. Minutes divided by 60 gives you the time in hours. Okay, we then put those figures into the calculation. So 4 kilometres divided by 0.25, if you put that into your calculator, it will give you an answer of 16. So her speed travelling to the post office is 16 kilometres per hour. Okay, question C, how long did she spend at the post office? Well, we can see for the graph she arrived at 11:20 and she left at 11:40. So the flat part of the graph starts at 11:20 and ends at 11:40. So the difference between 11:40 and 11:20 is 20 minutes. So she stayed in the post office for 20 minutes. And the last question asks us to work out her speed going back home. So she leaves at 11:40 and arrives at 12 o'clock. Okay, so 20 minutes from 11:40 to 12 o'clock, we want to turn that into hours. So like we talked about previously, we want our answer for speed to be in kilometres per hour. So our 20 minutes that she took is going to be converted into hours by doing 20 divided by 60, which gives you 0.3 recurring. Okay, we then put that calculation into distance divided by time. So 4 kilometres divided by 0.3 recurring will give us 12 kilometres per hour. If you're using a calculator to work these questions out, it's helpful just to use your answer button. So you would do 20 divided by 60, which gives you 0.3 recurring on your calculator. You can then just do 4 divided by answer, and if you've got that type of calculator, you can hit the answer button, and that will give you exactly 12 kilometres per hour. If you round the number, the 0.3333, you will get an answer that is very close to 12, but not quite 12. So it's useful to use the answer button on your calculator to have that accuracy. Okay, so let's just recap. If you want speed in kilometers per hour or in miles per hour, and you're given the time in minutes, you need to convert the minutes into hours. So the formula for that is the number of minutes divided by 60. And that will give you a decimal number, which is the time in hours. Really common mistake people make is to think, if we just flick back to this one, we can see, for example, here, that we wanted to turn 20 minutes into hours. A really common mistake, people think 20 minutes will be 0.2 or 0.20, which is not the case because minutes are not out of 100, they're out of 60. So we need to use this formula, the number of minutes divided by 60, to get the time in hours. Okay, so here's another example. If you wanted to turn 10 minutes into hours, 10 divided by 60 gives you 0.16 recurring. 42 minutes into hours, 42 divided by 60 gives you 0.7. Okay. So there are a few that hopefully most of you will know without having to actually do that calculation. 15 minutes, most people know that's a quarter of an hour, and a quarter is 0.25. 30 minutes, again, most of you will know that's half an hour, which is 0.5. And 45 minutes, some of you may know that's 3/4 of an hour, which is 0.75 hours. Okay. What I've done next is you've got 3 questions on the next 3 slides for you to have a go at. The first one is the easiest, a little bit harder and more difficult for the third question. Once you've done those questions, and I will send you the PowerPoint separately so that you can do them, print them off and do them that way if you want to. Then the last task is to do the math swatch. Okay, so I want you to go through this video first, make sure you can do these questions, and then go on to the math swatch. And obviously, if you do need any help at all, please do email me or email your math teacher to get some help. Okay, thank you for watching and take care.